My name's Todd Fine. I am a director for a company called RDA Corporation. We're a software development consulting firm. And I'm also the Microsoft regional director for Atlanta. That just means I get to do a lot of cool stuff with the Microsoft product teams and the developer evangelists. Today's agenda, very simple. We're going to do two things. We're going to look at an overview of Avalon, describe where it fits in with Windows and WinFX. Then we're going to focus on one particular portion of it, the XAML markup language. So let's jump right in. We're in the middle of 2005. Sometime next year around the holidays, Windows Longhorn will come out, the next major release of Windows. And that's going to come with a new API set that goes beyond Win32. It's going to come with the WinFX API. And Avalon is a part of that WinFX API. So this is a big deal. Sometimes people don't get it. There's only been 3 APIs for Windows since its inception: MS-DOS, Win16, and Win32. So WinFX is a from-the-ground-up, brand-new API for Windows. It's a big deal. And WinFX at this level is made up of 3 pillars: Indigo for communication, WinFS for data storage, and Avalon, which is the presentation subsystem for WinFX. So that's where it fits into the whole Windows WinFX context. So what's Avalon now? Avalon's the code name for the unified presentation class libraries in WinFX. It consists of a display engine and a managed code framework. Now when you see the code, as we show you later, it's going to look a little like web programming because it's got markup language in it and procedural code. But I want to make one thing clear. This is not server-based programming. Avalon is for building client apps on your local processor. So what is Avalon made up of? Avalon's made up of 3 pillars. The first is a new vector-based rendering engine. And that's important because Windows, up till now, has been bitmap-based. You do graphics through bitmap manipulation. Vector-based graphics allow you a lot more flexibility, a lot more power. If you blow up a graphic or a piece of text in Windows now, you get the jaggies, right? If you blow it up with vector-based rendering, you do not. The second thing to point out on this slide is that Avalon goes directly in its stack to the DirectX 3D engine. So that means Windows will now be able to take advantage automatically of any hardware acceleration built into the computer. If 2 years from now you buy the latest NVIDIA 𝘿𝙞𝙬 2000 GeForce hardware acceleration display, all your text, all your graphics and rendering will be displayed with the full power of that hardware. Avalon's also made up of a managed code framework, presents a unified syntax and programming model for programming all aspects of your GUI. Your procedural code, your graphics, your 3D modeling, your document services, everything. Avalon apps can run standalone, like a regular client app in its own window, or it can also run hosted in a browser with no code changes whatsoever. You just flip a config switch. The last pillar, of course, is this XAML markup language that lets you declaratively define and represent your user interface. It prevents a nice clean separation between user interface design and underlying code. But before we get to the code, I want to make one more important point. You hear about vector-based engine, you hear about XAML. Avalon is much, much more than that. It includes an entire set of technologies not currently existent in Windows. It includes full 3D capability. It includes subsystems for storyboarding and animation. It includes an annotations framework so you can do things like margin callouts and sticky notes and highlighting that previously you'd have to buy third-party tools for. It includes an Avalon data services architecture that lets dynamic properties of any UI element be bound to underlying data, like a database table, a custom CLR object, anything you can think of. It includes an Avalon document services framework. All kinds of stuff is not available in Windows now, so it's a very broad and very deep set of technologies. All right, we're at TechEd, we're coders, let's talk about code. XAML, it stands for Extensible Application Markup Language. It's the markup language for declaratively designing and creating your application's UI. So you see a little snippet here in yellow. It's got a button that just displays in the form, very simple. XAML, for every screen of stuff, every page in a browser, every screen on a standalone window, requires one root tag for the XAML. And that's generally an output service. In this case, you can see it's a canvas, but it could be something called a doc panel, or a flow panel, or a text panel, or a table, or a grid. You can nest these kind of surfaces inside each other and get very fine-grained control of your GUI placement. Now, it's important to understand XAML stands alone as a graphics definition language. It's not hooked up to anything else. It stands by itself. But Microsoft has taken it and integrated it with .NET and WinFX and the Visual Studio tools to give you a really powerful environment set of tools for creating these apps. So every tag in XAML maps directly to a .NET class. And every attribute in XAML maps directly to a .NET property. But it's really independent. So why are we doing this? This is the big question you always get. Why has Microsoft done this? Well, there's 4 or 5 reasons I can go into, but in 10 minutes, I had to pick one. So I'm going to pick the fact that programming and markup do not currently coexist very well together. That's a basic reason for creating this. Code's great for logic, right? You can do complex if-then-else and business stuff, but it's very clunky for managing graphics. Markup's great for doing graphics. That's why HTML was successful, right? It's easy to do, but it's very clunky for doing business process logic. So Avalon meshes these two technologies really well. Provides a unified approach to combining markup language and procedural code for building applications, and it makes a very clean separation. So, provide one quick example. This is a Hello World app built in C#. Now, you can see I added a little extra stuff to it to make it more interesting. I put a background color on there. I put a different kind of font. I centered it horizontally. But the code you see on the screen is the actual code required to do this Hello World app. And that's kind of ridiculous. What's it look like in XAML? Basically, one line of code. It's a text panel with Hello World in it. Very intuitive. Background equals this. Font equals that. Alignment equals this. Very simple and intuitive to use. That shows you some of the power of why XAML can make your coding easier. Let's do a really quick demo of that. So here I have helloworld.xaml. I'm going to open it up in Notepad just to prove that it's the sample I just showed you. So that's what it is. And because it has no procedural code in it, no C# or VB.NET, nothing needs to be compiled, I can just double-click on it and it will render in a browser. So there's your simplest possible Hello World application done in XAML and using the Avalon engine. All right, back to the slides. In the real world, you're not going to use the famous Notepad application. You're going to open Visual Studio and build some enterprise apps. How has Microsoft integrated that and made your life easier? When you generate an Avalon project, it's going to create 2 files for each page of stuff, each page of graphics and text and rendering you're going to do. A XAML file and an associated code beside file, in this case C#. The XAML file is for your markup. The C# file or VB.NET file is for your procedural code. So you can see here at the top, it's the same button example I've been showing, but it's got a click event. It's got a user interaction. So that would be handled by the code beside file below, and you see it handling this button click event. You'll also notice that it has a partial class here. Partial classes are new in .NET 2. A partial class allows you to break up your class into different bits that's stored in different files. That's all it does. Let me show you what Visual Studio is doing behind the scenes. When you compile this Avalon application, when compile, the XAML parser converts the markup into a partial class itself that contains the equivalent object model code. When you build it, you build your project, the partial class created by the XAML parser is combined with the partial class from the procedural code into one page. So let me show you how that's going to work right now. Back to our little demo. Now, if you use the CTP, Community Technological Preview, or the betas, you would go to Visual Studio, open your project, and you'll see, when the dialog comes up, new projects for Avalon, Avalon Control, Avalon Library, etc. What I'm going to do is just open a previously built file, which is just a plain Jane generated new project with one button-click event in it. You'll see on the right, you have page1.xaml for the markup, page1.xaml.cs for the procedural code. This is a button inside a doc panel. Notice the class is dynamic XAML.myPage. It's going to be the partial class. It's got a button and it's got a click me in there, and it's got a handle click event. Let's go over to the associated code beside file. Look at this. Dynamic XAML. The class is myPage. It's a partial class. And here's the handle click event. And if I run this, you'll get your first Avalon application. It should just show a form with a little button in it, and that button just changes when you click on it. And that, in a nutshell, is Avalon and XAML. It's the end of the presentation.